cares? Okay.
Professor, we want to have
What?
Should I stop? If I start?
Yeah, quizzes are always on. Don't wait.
I started already. Should I turn it off until you start? Then turn it on.
You already have it on? Well,
Sorry, I thought you wanted to start.
Yeah, we should probably restart because that's like a 1 minute.
Should I?
you're big.
I thought you were going to start.
Wasn't even ready. Questions on 2.3? 2.4. 2.4. Okay, 2.4 is.
Professor, we need to calculate these two different formulas, so can we use it for today?
What?
Formulas.
No. All right, questions.
26 x squared sine x tan x.
You're to differentiate, right?
Yeah.
I just saw a similar problem like this. Okay, how do we attack this?
You make it to like F, G, and H. Yeah?
Okay, F, G, H.
So first you find the derivative of F, you ignore G and H, and on the next you put the plus in the middle and you go to F and you find the derivative of G and you ignore F and H and add again. You find the derivative of H and you ignore F and G.
Right, so there is, there's a way to generalize the product rule, which is what he basically just gave the formula for.
Yeah.
Basically what the product rule says, in a product, each factor gets to be the derivative once, right? That's basically what the product rule will say. So if you want to find the derivative of f times g, what do you do? In one case, f gets to be the derivative, and g just times out. In the other case, g gets to be the derivative, and f just times out, right? Turns out you can actually just generalize this if you have, say, three terms, f, g, h. What you can do is, in the first case, f gets to differentiate himself. Then in the second case, g gets to differentiate himself. Then in the third case, H gets to differentiate himself, right? Every guy just differentiates himself one at a time, right? While everyone else stays fine. Can't everyone do it at the same time, too much chaos, right? But basically this is what happens, right? And of course if you have a product of four terms, then you have, four summations, and then you just, each factor gets to be derivative once. And that's what we're going to do here. So we actually have three functions being multiplied. And we differentiate it by differentiating them one at a time and adding it together. So this would imply that y prime is equal to x squared has to be derivative.
2x.
Leave everyone else. Plus, now leave x squared, the sine gets to be derivative. Then plus
X squared sine x. Secant squared.
and that's sort of it. We can't really do much here. Maybe factor out
Sine.
x times sine.
No.
We
It
do
doesn't
that,
go
but-
along with the. We go
negative tangent plus x plus x secant squared. I mean, we can't really do more than that. That's fine. I don't see the benefit of trying to simplify anymore. But yeah, so that's the moral of the story. You have several products. You can just extend the product rule by taking the derivative of each factor once.
But again, on the second step, I don't know how you got that. Like, how did you take the
Oh, the tangent
sine over cos?
is sine over cosine. So this cosine is going to cancel with that, and then I took out that sine and one of the x's. So it just left with x. Other questions?
If you go 48,
48. What does that say?
it's like y equals x minus 1 over x plus 1.
Yeah?
Oh, and then he was like, and then it said find the, I think, and then it said find the line parallel to x minus 2y equals 2. Find the line parallel to x minus 2. You just gave it that, and now that you got that.
Do you mean tangent lines?
Yeah, the equation of the tangent line that parallel to the.
Oh, yeah.
Equation of tangent lines parallel to what was the line?
X minus 2y equals 2.
Okay, how do we know that two lines are parallel?
You get the slope.
They need to have the same slope. That's how you know the lines are parallel. So what we're going to do is, this is the line, what is the slope?
2y equals 1/2 2y plus
Here you know slope equals 1/2, right?
Yeah.
So this means we want the slope of the tangent line
To be 1.
to equals 1/2. But the slope of tangent line is just a derivative, right? This means we want y prime to equal to 1/2. But what is y prime?
So you do the quotient rule.
That's in the quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So this kills that. We just get 2 over x plus 1 squared. And we want
We have to make it equal to 1.
2 over x plus 1 squared equals a half. This means x plus 1 squared must equal to 4.
Square.
This means x plus 1 is plus or minus 2, so x should be minus 1 plus or minus 2. So x can be either minus 3, or your x can be minus 1 plus 2, which is 1. So there are two options, right? The tangent lines to this curve will be parallel to this at two possible x values, either minus 3 or 1. So you'll have two tangent lines here that do the job. So when x equals minus 3, this means your y value would be what? 2. Minus 3 minus 1 over minus 3 plus 1. This is minus 4 over minus 2, which is 2. So we know that x1, y1 would be the point minus 3 comma 2. With the slope, we want to be a half. Right? So the tangent line here is y minus y1 equals m x minus x1. Or you can have the other option when x equals 1.
1 minus.
So then you have y would be equal to 1 minus 1 over blah blah blah. It's going to be 0. So this means x1, y1 equals 1 comma 0. My slope equals a half.
Y minus.
So the tangent line is y minus 0 equals n x minus 1. Okay? So this was the important part of the problem. Here, you want the slope to be equal to whatever the slope of this is, it's parallel. And if you wanted it to be perpendicular, of course, the slope would be -2 when you do the same thing. Other questions? Any questions about this? Other questions?
Oh, can you go on, so what number 34?
34.
Yeah. F(x) equals secant. And find the second derivative of pi over 4.
Okay, find f double prime of pi over 4.
So you find the derivative and then
First find derivative.
Yeah.
Derivative of secant is
Secant x tan x.
Yeah.
Then find the second derivative. Secant x tan x.
which rule do we use?
We use the product rule.
Product rule. So we have one function times another, right?
Yeah.
So what we're going to do is we're going to differentiate secant, leave tangent alone. Derivative of secant is secant is tangent x, leave tangent x, plus now we leave the secant x times derivative of tangent. So what we have is we can factor out a secant, that's a common term, we'll have tangent squared x
Plus secant.
plus secant squared, which isn't really anything. So I guess at this point you just plug in the value. By the way, the problem is to find something plugged in at a value, I wouldn't waste a lot of time simplifying anyway. Just plug in the number right away and work it out. So what's secant of pi over 4?
Radical change.
Tangent of pi over 4? And then this is radical 2 squared, right? So it's 3 radical 2. Yes?
For that one, when you find the first derivative, you want us to state that it's not defined at pi over 2.
No,
So you're
no.
but it is undefined at pi over 2.
Yes, it is on the line. As long as the points I'm asking you don't interfere, just don't worry about it. Things like that matter more when you're doing curve sketching, and the derivative is actually going to tell you stuff about the curve that you have to draw, then you not worry. Can anyone tell me why it's not defined at pi over 2?
Sorry?
Why is this not defined at pi over 2? Yeah. Cosine pi over 2 is 0. Tangent is sine over cosine, and you plug in pi over 2, you get 0 in the denominator. What does that tell you about the graph of secant? It's not differentiable there, right? To say it's not continuous, you need further speculation. Secant itself is not defined at pi over 2 because it also has a cosine. But yes, later on we're going to use a derivative that tells us clues about the original function. So you can always keep in mind, oh, derivative is undefined. What does that mean? Let's keep looking at this. Any other questions? 32.
Oh, wait.
X over 1 plus x squared. Y is equal to x over x squared. 1 plus x squared.
And what's the question?
Tangent line of 3 and 0.3. Tangent line of the curve.
3, 0.3.
Yeah,
Want tangent line here?
yeah.
Okay. So how do we define tangent lines?
You find the derivative of the horizontal function first, and you
Right.
plug in the x.
Right, tangent lines are just straight lines. To find the equator of a line, I need a slope and a point. How do I find the slope? The derivative. So the first thing we're going to do is find the derivative, which is
I'll use a portion.
quotient rule, division. Okay, so how does it?
1 plus x squared times 1 plus x times 2x over 1 plus x squared bracket squared. So 1 plus x squared minus 2x squared. Or minus x squared. We have 1 minus x squared.
Alright, here I'll simplify just a little bit because it's actually not that difficult to do it. So now our m for the tangent line is just going to be the slope evaluated at 3. And so this would just be 1 minus 9 over 10 squared. Right? So this is just minus 8 over 100. Which is what?
Negative 2 over 25. Negative 2 over 25.
Right, 4 can go to each.
Yeah.
So that's our m, and we already know the line. So this implies standard line is y minus y1 equals m x minus x1. Everyone okay with that?
It's not
Huh?
this number.
Talking to yourself? So since there are no more questions, quiz today is really hard. No, this one I've outdone myself this time, really.
Let me guess, the Dream Killer remix?
See your lines, right?
I mean, I tried to do it, I had to check Wolfram, wait, is this right? Because I didn't know. It's like, wow, it was so hard.
So we.
Huh?
Okay,
You
so,
guys got so loud right now.
wait, what?
Oh my god.
What?
They were like, there's a quiz, and I'm like, don't try the boys, they're wrong. So you were joking, okay? And they fell for it.
Hey, what's the chain rule about? Well,
Can you pass up our homework?
So what?
let's say we have this problem, right? Y equals x squared plus 1 all squared. How do we differentiate that?
You would bring the 2 at the front and just leave x squared plus 1 alone and follow the
Well, are you saying you would?
You would bring the square at front.
Why?
Oh, wow.
It's gonna be.
You bring the exponent
in
in front,
Yeah.
leave the inside, and then multiply by the differentiation. Of the inside.
Would be 2x squared plus 1. So 2
X squared plus 1.
2 in parentheses x squared plus 1, and then
Plus
2x times
It's
2x.
basically the power rule with one extra step.
This is
Essentially.
power of one. Okay. All right. See, you guys are reading ahead.
You're having a really good day today.
Trying to get those bonus points. Okay. I said to someone like, oh, you multiply out, you multiply out and do the power rule, or you expand the square. It's not that hard because sometimes things don't look so nice as you've been finding out. All right, so yeah, if you want to differentiate a polynomial, no problem, right? Just use the power rule. If you want to differentiate two things multiplied together, no problem, use the power rule, the product rule. If you want to differentiate a quotient, use the quotient rule. Now there are other kinds of functions that look like this guy, where if you wanted to expand and use the power rule, no problem. But if you look at y equals something like x squared plus 1 to the 20, you wouldn't want to multiply out, right? Because that would take forever, right? So to deal with guys like these, hard before our 2.5 knowledge. To deal with guys like these, which are composite functions, use the chain rule. Right? Remember what composite functions are, right? Just functions within functions, right? So this is not just x to the 20, it's a whole function to the 20, right? There's a whole function replacing the x, right? Now the chain rule says the following. The derivative of f of g of x, right? So it's not just f of x, there's like a whole g of x. There's a whole function stuffed in where the x usually goes. What you do is you differentiate the outside function, leave the inside one intact, multiply by the derivative of the inside function. Right? And by doing that, you call it the chain rule. Should be memorized, right? There's another formulation that you might see in the textbook, which not a lot of people use, but right? It's actually just the same thing. The difference is we're talking about the U like the G, but it's the same formula. This is the one I memorize and I use it all the time. There's probably no use for this. Maybe the textbook might actually use it, but it's really just saying the G, the inside function, is the U. So you differentiate it with respect to U, which is this guy, and then multiply by the derivative of the U, which is that guy. Same thing. So in the example, y is equal to x squared plus 1 to the square, what you do is you pretend this is a single variable in the first case, right? You differentiate the outside function. The outside function is the square. We know how to differentiate squares by power rule, so we do that. Right? Leave the inside function intact. Don't do anything with it just yet, right? That's why it's still just g of x. Then, because it's not just x, you have to account for that somehow. You multiply by the derivative of what's inside, which in this case is 2x. So your answer here would be 4x times x squared. Right? That would be the derivative. X squared plus 1 to the 20, sort of the same thing. Think of this as something to the 20, right? So you can apply the power rule. Bring the power down, subtract 1 from the power, but because it's not just x, it's a whole function, multiply by the derivative of the inside. So here, this would just be 40x x squared plus 1 to the 9. We'll skip the proof because it used a lot of epsilons and deltas and we didn't really talk about those, so probably wouldn't be very enlightening. So the idea is you use the chain rule when it's not just an x, it's like a whole function instead of an x. Okay, so let's do some more examples. let's start with over here. Derivative of y equals sine squared x.
Take that too long.
Okay, the trick is to think of this as sine x all squared, right? And so y prime would be 2, just do the power rule, leave the inside intact, and then you multiply by the derivative of the inside, which is sine 2x. Notorious mistake is thinking that the derivative of sine squared is cosine squared. It's not, right? This is sine times sine. It's not the same thing as saying cosine squared.
2x cosine squared.
What?
That's a trigger. 2 sine x plus sine x equals sine.
Do we have questions on this?
It's that annoying double angle.
What did you say? Yes, this is
There's
the
the
trigger.
formula for double angle, right?
Yes, double angle formula. Yeah, 2 sine x cosine x is sine 2x. That's a double angle formula for sine.
2x plus.
Cosine x squared.
Right. So here it's not just sine of x, it's sine of a function, right? The sine is the outside function, right? Over here the square was the outside, over here the sine is the outside. So y prime is differentiate the outside function, leave the inside intact, then you multiply by the derivative of the inside function. Right? So this is just 2x cosine x squared. Okay. Oh, this one.
Negative x over square root of 2 minus x squared.
Did you get that? Tell me the steps. We're not as smart as you. What are the steps? Tell me the steps. How do you get it?
Set it to the 1/2 power first.
Right, you decide to rewrite this as the 1/2 power, sure. So it looks sort of like the power rule, except it's not just an x in here, right?
Oh.
So the half is the outside, the half power is the outside function. Then what did you do?
Then use the power rule.
So now y prime is going to be the power rule, so we bring this down. Minus a half. Then you have to multiply by the derivative of the inside function, right? Which is minus 2x. The 2 would cancel the 2 here. And so you just have minus x. Which if you'd like, you can simplify that to the homework, I think, has a lot of problems about recognizing when you have a composite function, when one is an outside and the inside, and determining who's. Okay, how about this one?
Quotient time.
Right, so it's like the quotient rule. I have one function divided by another. This is my f over g. So what's the derivative?
It's going to be x plus 4.
The bottom times the derivative of the top, which is just 1, minus
x plus 1.
the top
6
times the derivative of the bottom.
16 times x plus 4 to the power of 15. Times 1.
Times 1, right? The trick here is for the bottom you needed to use the chain rule, right? But here the derivative of the inside is just 1, so it actually won't look much different from the power rule.
Over x0 is still
What?
No.
This is 32. Can we do anything here?
You can factor out a x plus 4 to the 15th power.
Right. Whenever you see common factor anywhere, you factor out the lowest power, which in this case is 15. So I will take out x plus 4 to the 15. And I'd be left with x plus 4 in the first term minus 16 x plus 1.
Over.
Should be able to do it. Okay, so now we can actually simplify, right? X plus 4 to the 15 goes into this how many times? What's left?
17.
17. And then this guy here is just minus 15x
Minus 12.
minus 12. That's up. Here. Y prime. Quotient rule again, right? We have a division of functions, we're going to apply the quotient rule. Power rule works nicely on the top, however the bottom is cosine of something that's not just x, cosine of some whole function. So it means we need the chain rule to differentiate the bottom part. So it's the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom. How do we do that one?
Minus x times sine negative sine.
Right? The outside function is the cosine, the derivative is minus sine, leave the inside intact, then you multiply by the derivative of the inside.
All over cosine.
Any questions on that so far? You have a question?
Wait, Professor, don't the square have to be for everything?
Yeah, that's the notation for the square. Right, when you put the square on the cos, it means the whole thing squared.
Wouldn't you do like bracket cosine x cubed and square from
Well,
outside?
It's the same thing. It's the same.
The x cubed would not become like x5?
No. That's why I didn't put it at the end, because people might think that. If you see something like cosine of x cubed squared, that's sort of telling you that the angle is squared, right? So you have to be very careful to put the brackets here. But if you see something like cosine squared x cubed, that means the square is applied to everything. It's a notation thing. Once you put the square right after the cosine, it's telling you the whole thing is squared. It's notation. So now we just have cosine x cubed minus, well, minus times minus is plus, 3x squared times this, 3x cubed sine. Can't really simplify it, leave it like that. left enough space for that. You have to write very small. Okay, how do we do it?
So we will make it secant square sine x cubed.
So tangent is the outside function, alright, cool, so we derive that as secant squared. Leave the inside function intact. Now we have to multiply by the derivative of the inside, right?
So it's cosine x cubed.
Cosine of x cubed
Now we have to do the inverse.
times 3x squared. Alright? You actually have to apply the chain rule again, because the inside function is itself a composite function. So when you're trying to derive that, you have to think of the sine now as the outside, so you differentiate that, leave the inside intact, and then multiply by the derivative of the inside. You actually apply the chain rule twice.
Yeah.
So this is just,
3x squared.
can't really simplify this.
Close. Yeah.
And I believe there's like a homework problem that's like, you know, like tangent of sine of cosine of x. There are problems that I don't know. You wouldn't even get something like that on the final. I don't think, unless
Inside
they
of
want
trig
to be
functions.
mean.
Inside of trig function section. It's inception.
A dream within a dream. Yes. A derivative within a derivative.
I guess.
You guys saw that exhibit meme with the chain rule? You guys know? Alright, how do I do this one?
Product rule.
Find the derivative using the chain rule.
Wait.
Product rule. So we have two functions here being multiplied by each other. However, each function is a composite function, which means to differentiate each part, I will need the chain rule. So
First, we take the 8 out.
So now let's differentiate this one, leave that one. Time to derive the inside
Just two.
is 2, and you leave this guy alone.
Wait, so what's considered here the outside function?
There is no, it's just an F and G.
So this here is F, this here is G, and this here, I just took F prime.
Oh, you're doing,
Right?
okay.
Yeah.
So
Doing the product
I
rule
thought
with this
it
the
change.
outside function is the 8th power. So I bring the 8 down to the 7, and I have to multiply through the inside.
So is it the chain rule or the
I just did the chain
It's
rule.
both actually.
We're doing both at once. That will happen. I mean, if you only have to use one rule, life would be boring, right? You have to make that.
I'll be perfectly happy using this.
Plus, we leave this one alone. And multiply by the derivative of the other.
Which is bring the 5 out. Yeah, we need more space. Just more.
2x.
2x. And this is the f times the g prime.
And
But now we can simplify, right? And you would be expected to
You can
simplify.
multiply 8 times 2.
well, we can actually just factor stuff out and it'll make like
Just start factoring stuff out. So what are our common factors?
x squared
There's
plus
a 2.
1. Oh, that too.
There is the 2x plus 1.
To the 7.
The powers are 7 and 8. You take out the lowest power. There's an x squared plus 1. The powers are 5 and 4. You take out the fourth power.
Okay. What is left?
That's it.
Which is.
Alright, so I took out the 2 that's gone. There's just an 8 left. I took out the 7 of these, but I only took out 4 of these.
You're still
So
left with that one.
there's just 1 left here. Plus. Right, there were 8 factors. I took out 7 of the factors, so there's just 1 of the factors left. There's a 5 left. 2 I took out from here, so there's just the x. Plus 10x squared plus 5x.
18x squared.
That is it.
8x squared, 8x squared plus 8.
What?
8x squared plus 8.
Plus 8. Oh, yes.
Whoa.
See, I was testing you guys. You guys missed that. You guys always fall into all my traps. Okay, anyone think they know how to prove the quotient from the product rule?
Oh dear. Wait, prove the quotient from the product?
Yes, using the chain rule.
Wow.
The product rule says, of course, f of x times g of x. If I have f over g. Huh?
Oh, f of g, just you use the quotient rule.
No, we pretend we don't know the quotient. We only know the product rule and the chain rule. How do we get the quotient rule?
So you do g times.
Well, if I want to use the product rule, what do I have to do?
You just take the z on the top.
Write it like a product. Take the g on the top, right? So this is just f times g to the minus 1. Right?
Yeah.
But remember, this g is a function, right? It's really g of x. So if I want to differentiate this, what do I do?
Now you use the product rule.
Apply the product rule. So this is f prime times
G
g
negative 1
plus
f
f times
negative 2, no, negative 1 g negative 2
minus
power
g to the minus 2 times g prime.
Oh.
Right? And now you start to simplify, right? So now you can factor out, you factor out what?
g. Our atom.
What do you factor out?
Factor of g negative 1.
There are 2 powers of g. Negative 1 power, negative 2 power. Who gets to come out?
Negative 2.
Negative 2. You always take out the lowest power, right? So you can take out g to the minus 2. And what would you have? F prime times, this would just be g.
Yeah.
Because when I add minus 2 times with a plus 1, I get a minus 1.
Plus
Minus f times g prime.
Over g
But
squared.
this is g to the minus 2. That's just over g squared.
Which, holy crap.
So this sort of gives us more options if we're looking at functions like like 3 over sine of x cubed, right? There are other options other than you just jump, quotient rule, right? You could actually, using the chain rule, you just rewrite this as sine x cubed to the minus 1. And now you know how to differentiate something like that using the chain rule. And so now your y prime is, this is just a constant, so really just leave it there while you differentiate this, because we have the chain rule at our disposal. Minus sine x cubed to the minus 3 times cosine
X times 3x squared and
yes.
So in order to not to confuse yourself. How do you know when to use the product rule and when to use the chain rule?
Wait, hold on, let me just finish this. So this is cosine. At this point, personal preference. If you like the quotient rules, you do that. If you prefer using the product and the chain rule, you can do it this way. Just showing you that now you have options. Because really, the quotient rule is just applying the product and the chain rule at the same time.
Okay, at that point,
So,
stop.
yeah, we're fine here. We can't do that.
Because I was asking, how do you not confuse yourself?
Wait, you have a question? This one? From the -1 power. All right, pass up your homework and get out of here.
Because I was asking, how